predict what will happen if a molecule of bromine is added to a solution containing the sodium chloride and the sodium iodide at 25 degrees Celsius, assuming all the species are in their standard state. So basically we have a sodium chloride and the sodium iodide. Now we have to see what will happen if you add a bromine. So basically the possible reaction here is that the bromine molecule may react either with the chlorine or with the iodide. We are given the reduction potentials of the different species here, the bromine, chlorine and iodine. So now you can see from here, from this data, you can see that the reduction potential of the chlorine is more than the bromine. So chlorine has a higher reduction potential than the bromine. So which means that the bromine molecule cannot take the electrons from the Cl negative because chlorine has a high reduction potential. High reduction potential means that it has high tendency to gain the electron compared to the bromine. So that means the bromine cannot take electrons from the chloride ion because chlorine has a higher reduction potential. But if you look at this reaction, the reaction between the bromine and the iodide, you see that the iodide has a reduction potential of 0.53 only. So bromine has high reduction potential than iodine. So which means that bromine can take the electrons from I negative, and now it will form the Br negative here. It will take the electrons from the iodide because bromine has a higher reduction potential than the iodide. So that means the now you can say 2 iodides will react with the 2 bromine, so you get the I2. So this is the reaction that will take place when you add a bromine molecule to the mixture of sodium chloride and the sodium iodide. Next point is we have to find out the reducing power of the different species A, B and C and their reduction potentials are given, right? Reduction potentials are given. So we know that if you have electrochemical series, and in the electrochemical series, we arrange the electrodes according to their, this reduction potential. So if you go down this series over here, you see that right at the top we have the lithium in this series, which actually has a very high oxidation potential. I can see it has a very high oxidation potential, means it has high tendency to lose the electron rather than to gain the electron, right? So it has high tendency to lose electrons. So this will be having a very, very low reduction potential. This has a very low tendency to gain the electron, right? And as you go down, you see that those tendencies, the tendency to gain the electron, the reduction potential, now that starts increasing. So down the group, you see, down this series over here, you can see that the reduction potentials increase, which means that the reduction potential increase means that the tendency to gain the electron will increase. Correct? And reducing power is related to what? This reducing power means if you have an atom A, suppose you take a sodium and you have a chlorine, and we know that in this case the sodium will lose electron, chlorine will gain, and we find sodium form is Na positive and the Cl form is the Cl negative here. So in this case we can see that the sodium has a high oxidation potential. It has a very high tendency to lose electron, so which means that sodium is a good reducing agent, right? So I can see this is it has a good reducing power, right? It is because of this sodium the chlorine has been reduced. You can see the chlorine gains electron and forms the Cl negative. So this is reduction here. So chlorine undergoes the reduction. So we can say here that the tendency to to reduce the other element is what we call as the reducing power. An element, a compound that has high oxidation potential, an element that has a high tendency to lose electron will be having a higher reduction, this reducing power. So as you go down the group, this tendency to lose electron decreases, which means that the reduction potential decreases. So as you go down this series, the reduction potentials increase, the standard reduction potentials increase, but their oxidation potentials decrease. Correct? Oxidation potentials decrease. So reducing power is actually related with the reduction of the other element. So suppose you compare the sodium with the chlorine, and you can compare, for example, the iron with the chlorine. You can see here in this case we have a iron over here and we have a sodium over here. So sodium relatively has a high tendency to lose electron than the iron. So that means you can say sodium is a better reducing agent than the iron. Iron can also donate electrons to the chlorine, but if you compare the sodium and the iron, we can say the sodium has high reducing power because it has a high tendency to gain, to lose electron. So reducing power is actually related with the property of an element to lose electron. So when it releases the electron, the other substance will be reduced. So reducing power of an element is related with the oxidation potential. Higher oxidation potential means a better reducing power. And as you can see, the reducing power, the standard reduction potentials increase here. So that means their oxidation potentials decrease, which means that the reducing power decreases. So here among the three, we can say it is this one, the B, that should have the high oxidation potential, means it should be a better, it should have a higher reducing power. So the order now, the order of their reducing powers will be the B, and then you have a minus 0.5, so that which is C, and then you have an A. Now related to the oxidizing power, oxidizing power is actually the inverse of the reducing power. So what we so far learned that down this series over here, the tendency to gain the electrons increases, right? So the tendency to gain the electron increases because that is what you call as the reduction potential. So when a substance takes electron, it has a high tendency to gain the electron, means it is a better oxidizing agent. It has a higher oxidizing power. So you can see among these elements here, I can see the fluorine is having the highest oxidizing power among these elements, right? Because it has a very high reduction potential, it has high tendency to gain the electron. It has a high tendency to gain the electron, and that means this fluorine will oxidize the other substance very easily because it has a high tendency for the electron. So that means the element with the higher reduction potential will have a higher oxidizing power, right? The element with the higher reduction potential, higher standard reduction potential, will be a better oxidizing agent. So you can say among these three, you have 2.54, minus 2.54 and 0.34. So the higher one is A. So first one is A. So this is a better oxidizing, it has a better oxidizing power. And then we have the plus 0.34, which is C here. And then you have the B. So this will be the decreasing order of their oxidizing power.